So this is my video on 2.3, which is differentiation formulas. Okay, so until now, right, when we want to find the derivative of a function, we need to use the limit definition, which is this, right? And it is not the easiest thing in the world to do that, even for the simplest function, right? Even when we have a function like square root x, right? Okay, or 1 over x, it's not the most easiest thing to do. But the nice thing about this definition is it really shows how it happens, because this is like the change in f and this is like the change in h, right? And it's like the instantaneous rate or the slope of the tangent, right? So you can clearly visualize what's happening. But for calculation, this could be cumbersome. But fortunately for us, people have created a number of rules or formulas which will help us actually to find the derivative of any possible function. Okay, any function where the derivative exists, right? So let's look at some examples. So first of all, if you take the constant function, right, like f of x equals 5, right, because this is a flat line, right? Okay, so it's a flat line. So the slope of a flat line is 0. So the derivative is 0. Okay. So now let's call the constant rule. And let's look at another rule, right? If you have a power, now this I'm going to skip the proof, but I'm going to just tell you how to find the derivative. So if you want to find the df over dx, right? Okay, dy over dx, then what you do is you take the n, the power, okay, into the front, and you subtract 1 from the power. So for example, if you have x to the 5, if you want to find the derivative is you bring the 5 down to it becomes 5 times x times, and the 5 becomes 4. So 5 times x to the 4. All right, so let's take another example. So let's say take fx equals square root f x. So I mean, this is nothing but a power. So x to square root x is the same as x to the 1 half. So you can use the same rule. So how the half comes up in front and x, and then you subtract 1 from half, so you get negative 1 half. So if you simplify this a little bit, because we don't really like to use to leave the answer with negative exponents, bring it down as a positive exponent. You have half in front and 1 over x to the 1 half, and x to the 1 half is square root x, so is 1 over 2 square root x. Okay. Let's go to another example, 1 over x squared. Now, this is again is an exponent, is x to the power negative 2. So if you take the derivative, the negative 2 comes up in front, and then you get x, and the negative 2 subtract 1 becomes negative 3. Again, you want to bring it down, so you get negative 2 over x to the 3. So that's actually called the power rule. So just when you have simple power. So now the next rule I'm going to do is, okay, now if you just have a constant, the derivative is 0. But what if the constant has what if a power has a constant multiple? So to take this, so you have a power and also a constant. So whenever you have a constant, the nice thing about attached to a function, not alone. If it's a constant is alone, then it's 0. If it's attached to a function, you can just take the constant outside the derivative. So that means it's 3 times, and you just leave the constant as it is, and you differentiate the x to the 7. So it will be 3 times the derivative of x to the 7, which will be 7 times, 7 goes in front, and x to the 7 minus 1, which is 6. So it's 3 times, 3 is outside, and 7 times x to the minus 6, which is 21 x to the 6. Likewise, there is another rule, which is the sum rule. And the sum rule is that if you have a sum of several functions, right? If you want to find the derivative of the sum, all you need to do is to take each piece and find the derivative. So if you take this sum, take the first one, well, then it's the derivative of this plus the derivative of this, right? Okay, and that you can take the 2 outside there, and the derivative of 7. Well, the derivative of 7 of course is 0, right? And the derivative of 2x to the 7 is 2 is a constant, so 2 times x to the 7 is 7 times x to the 6, right? What about this one? So we have 2 times the derivative of square root x, we know is 1. We found that earlier. It's 1 over 2 square root x, so it's we have 2 times 2 times 1 over 2 square root x, and the derivative of 7 is just 0. Okay, so 2 times the derivative of this is 7 times x to the 6. Derivative of this is 2 times the derivative of this is 1 over 2 square root x, plus the derivative of the constant is just 0. So here you can cancel out the 2 and the 2, and you get 1 over square root x. So here you get 14 x to the 6, so it's 14 x to the 6 plus 1 over square root x. Let's take another example. So if you take this one and you want to find the derivative, there are several pieces. Take one by one. The first piece is this is a polynomial, right? Okay, so the first piece is 5x to the 4, 5x to the 4. Second piece is 2 times x to the 4 is 4x to the 3, so is 8x to the 3. And 3x, the derivative is just 3, and the derivative of 6 is just 0. So 5x to the 4 plus 8x3 plus 3 plus 0. Right, okay, so so that is the derivative. Find the equation of the tangent to y equals square root x at y x equals 4. So that's the question that we have. So the first thing that you need to do is to find the derivative, right? So the derivative will be, so because this is square root x, like before, so we want to find the equation of the line tangent to that, okay? So you use the word y minus y1 is equal to m times x minus x1. So we already know what x1 is, right? Okay, x1 is 4, so this is really 4. And y1 you can find by plugging in 4 to this. So if you plug in 4 to this, you get square root 4, which is 2. So y1 is actually 2 and x1 is 4, but the question is, what do you put for m? M is the slope of the tangent, so which is the derivative, but now we don't have to use the limit definition. We can just find the derivative using the formula. So if you use the formula, is the derivative is 1 square root x is x to the 1 half. So the derivative of that is 1 over 2 square root x by using the power rule as we did before, right? And now we can just plug in for x. We get 1 over 2 times x is 4, right? And so 1 over square root 4. So square root 4 is 2. So 1 over 2 times 2. So 1 over 4. Once again, we are using the power rule and think of this as x to the 1 half. So the derivative, as we found earlier, here is 1 over 2 square root x. Okay, so just using that, you can get the answer pretty easily for even slightly complicated sum. But now so far we have learned how to differentiate a constant, how to differentiate a constant multiple, and how to differentiate a function, right? And how to differentiate a power using the power rule, constant rule, addition rule, constant multiple rule. But we have not done how to do products and quotient, and we will do that next. Thank you for watching.